Hello, everyone. Great to see so many joining already. Welcome to today's webinar with
Hello, Chris. Nice to see
Abotion.
you.
Good morning, Jan.
It's not good morning. We have already passed noon.
It's relative.
How are you doing? Good to see you.
Yes, nice to be here. Yes, very good. I think I'm going to see quite a few friends this morning.
Okay, but then the nice topic that you
It
invited
sure
for.
is, isn't it? Yes.
Okay.
Yes. Yeah.
So good stuff. I haven't seen you before.
Well, good to see you. And I think we'll then have a pretty active webinar today. We're gonna make just gonna wait till a few more minutes for people to have a chance to join, and then we're gonna start off with Chris, and then by the end of today, we're gonna have a good time for questions and answers, and you can keep posting them in the chat as well during the webinar. So I'm Gustav Kegesten. I'm the science director of Hub Ocean, and I guess I've worked with Chris for off and on for some years. So it's very nice to have Chris from dbSEABED here today with us. This is part of a bit of a webinar series that we are running to introduce people to the platform and the data we have. So today we're gonna be soon going over to Chris to really have a look at the new updated global seafloor models that we will show you. And then we're gonna go over and have a look at the Ocean Data Platform, how the data looks there. And I will attempt a live demo as well. We'll see how that goes. And then, yeah, we'll have some time in the end. Yeah, perhaps yeah, I think we're pretty much ready to start. Before you get the screen sharing, Chris, I'll just run to two intro slides. So this is what you're here for today, to discover the latest global seafloor substrate maps. And we, like I said, the agenda is essentially the next 20-25 minutes. Chris will talk about the dbSEABED data. We'll talk a bit about Hub Ocean, who we are, and how the data looks on the platform and what you can do there. And then by the end of it, there's going to be a little bit of interaction with a quick poll and questions and answers. And then you can be as active as you want in the chat during the time. And with that, I leave over to you, Chris. You're on mute, and I didn't do a very good introduction of you, Chris. So perhaps you start with that.
All right, I just unmuted, and I'm going to share. Okay. And we're off and running. Okay. Here we are. So that good stuff. That's the way we want it.
Looks great.
Okay, very good. So good morning, everybody. It's a very nice event here. I really appreciate working with Hub Ocean. They put a quality of delivery on the products that I can only yearn for. So I'm down at the coalface, and Gustav is up there on the surface, publicizing everything and distributing it. So thanks, Gustav. Yeah. Okay, so global seafloor. The science in this has made many attempts for a global coverage of seabed properties, but all of them have hit the sort of 10,000 samples level. And what we're trying to do is to really break through that, and I think we have. We're up at about 6 million observations. And there are all sorts of aspects behind that figure. For instance, how efficient is the system at bringing in new data? how does it operate, its quality control, and so on. And that's what I briefly want to cover this morning. So to give you an idea of the scope, as I said, we have over 6 million observational sites now. This map doesn't cover that density so well. Most of those 6 million are really in the inshore or the continental shelf areas. So this graphic here colorizes the point data by purple for rock, red for gravel, yellow for sand, green for mud. And so it gives a first level view of the diversity of the substrates in the world ocean. And you can see there are some very well-known features that are quite obvious, like the mid-ocean ridges and some of the platforms in the continental shelf areas. So it's a global system, but we're able to come right down to local level features. And here's an example from Bass Strait in the Australian region. Tasmania is up there to the left, and the blue dots are the data points. So you can see that there's a lot of data in the inshore, and that's one area we really concentrate on because it's so impacted by humans. And then you're looking to the left there, you see the Tasman Abyssal Plain, where I have to tell you there is almost no data in that area. So one of the functions of dbSEABED is to point out where the gaps are in the coverage and try to direct new ship efforts to fill in those gaps. This is a mapping of grain sizes in the Bass Strait area, and recently there's been a lot of new interest with wind power in this area. So dbSEABED doesn't only cover the superficial seabed, although that's overwhelmingly what it works with. We have also had campaigns into the subsurface, and this is a celebratory graphic just to show you some work that we did in the North Sea in the German context. So we do bring in ocean drilling program data and cores, but you know, it's so sparse on a global scale. You have to be really careful in using it. You have to go to the areas where there's concentrated data. All right, so on the right here, I've listed the leading features of the system, and I guess this is the take-home part of the presentation. So dbSEABED is large, but it's efficient. It works with Python, and practically all of its methods are automated, with the major exception being the data import. I know it's old-fashioned, but we actually do it pretty much manually. Sometimes we have computer assisted, but we do it pretty much manually. And we do believe that human eyes, with their skepticism, are necessary in this process. So here are some other important things about dbSEABED. The main outputs are in engineering units. This is a conscious decision that we made. And that means that they're numbers with units of measurement attached and uncertainties. So this is the direction we want to go in. We're not just into classification of the seabed. We really want to get at the properties. And the reason for doing that is that we want to interface with models, numerical models and machine learning models, process models and spatial models. So we really, really want to interface with models. And that means that we have to meet their numerical requirements. However, we do love word-based data. And dbSEABED, I think, is still unique in having an automated way of transferring descriptions to numerical estimates of the seabed properties. Grain size, percent of mud, carbonate, organic carbon, seabed strength, color, those sorts of things. We're really trying to bring in the word-based descriptions and form estimates of good estimates of those properties. Now, the importance of this is that 85% of our data is word-based data. You would never be able to produce a good mapping of the global seabed if you stuck with just analysis data. So word-based data is absolutely essential. Three other aspects. We're very conscious that if you employ just corers to core the seabed, you will end up with a totally biased view of what the seabed's made of. And the same, if you only use geological data sources, you'll end up with a really biased picture of the seabed. So we have a policy of diverse data inputs. We even use municipal surveys of beaches and offshore sediment resources to go into dbSEABED. It's a different view of the seabed, and by incorporating them, we fight bias. All right, so in the system, there's a lot of cross-calibration taking place, and that means that we're checking the data after it's imported, and we often decommission data sets. It's sad, but it has to happen. And those cross-calibrations also measure the uncertainties. Now, dbSEABED is research-oriented. I'm very proud of that. It's not a commercial operation. It's based in universities, and we're vendor independent, and we totally enjoy the international collaborations that go with it. So there we are. That's the take-home set of messages. All right, so what are the inputs? We don't deal with bathymetry. We're not a bathymetry integrator. And also, we tend to steer clear of acoustic classifications. It's not through any sort of jaundice against them. It's just that dbSEABED is used very often for ground truthing, and we want to avoid the circularity in that. So the only acoustic classification that we employ is for rock detection, exposed rock, which I think is pretty clear in all the classifications, so we're confident about it. So we use diver, submersible, grab, core, dredge, video. We use all those sources. We're mainly directed towards the properties of the seabed. So it's strengths, colors, compositions, and textures. So that's our orientation. A critical step forward in the design of the system was saying that we are going to output a top 20 of parameters, and here they are listed after all the housekeeping for databasing. Things like sorting, grain size, carbonate content, Munsell code, a roughness metric, so on. So this top 20 is very stable. We've been with it now for many, many years. It's served very well. And so this is what we supply to people, basically the parameters that everybody wants all the time. There are three data streams in dbSEABED. There's the numerical data type, there's the word-based data type, and then there's an uncalculated data type. And these are processed in parallel and only merged at the final stage before mapping. And that merging can be done as the client wants. So if the client wants to prefer numerical data, so be it. If they want to prefer the whole lot altogether, we can do that. So that's a fundamental part of dbSEABED. Okay, so the input data types. Here you can see sort of an overview. I've already covered three of the points there, but I will also say that we do import gridded and polygon data topologies. And they're very important in some areas. They're very important for the rock coverage. So it's not only point data. We do import things like polygons. And the second point I want to make from this slide is, there are many seabed types which you really cannot characterize with numbers. And here's a sort of a tour of some types of seabed where you really have to describe what's going on in semantic and word terms. And that's the other motivation for us embracing word-based data. All right, and how do we do that? Well, many years ago, I think there was a paper published in 1998. Yes, 1998, where we described how to transfer terms like sandy gravel, gravelly sand, muddy sand, and sandy mud into numbers. Basically, what we do is we run a calibration using a large data set like Jan Haaf's set in the Baltic, or the USGS East Coast Sediment Database, tens of thousands of samples with parallel descriptions and analyses. So we use all the samples where you have both, and then we can calibrate what is meant when they say it's gravelly sand. And the meaning of gravelly sand in terms of grain size is one of those color curves there. So for gravelly sand, it's the first orange one, and you can see that it's centered about 1.5 phi, but there are memberships for that term in a range of phi classes ranging from -5 to 4.5. So we tend to take the mode of that membership function as what the observer meant when they used that term gravelly sand. That's the essence of how we transfer the word-based data to numerics. All right, so turning now to Hub Ocean and how people can get data from dbSEABED. So this graphic here shows the currently served parameters for the global distributions. Again, they are backed by a mighty amount of data in practically all areas of the world. The Southeast Pacific is a problem, of course, but practically all areas have a decent amount of data now. I will just click here, and yes, so this is hard versus soft substrate. And there's a really interesting point going into the making of this. So it depends on the rock and gravel, sand and mud percentages, really. If you just map the reported rock records, you end up with a lot of the ocean is covered as rock in the interpolations from that rock data. So what we had to do was to turn around and use every record in the database where people had taken a sediment core and mark that as 0 rock. You can really only make a global coverage of the rock distribution by paying attention to the cores where no rock was found. And as an example of the 0 rock records that we have, and it's a vast number, we use the heat flow core database for soft sediments. So that gives you an idea of the diversity of data inputs that are needed to produce a sensible mapping of the world ocean bottom. All right, so how do we get these fully interpolated maps? We are very conservative at the moment on how we do that. And there are a couple of practical reasons why. I mean, we're dealing with seabed environments going from the beach to the Hadal trenches. The data is non-stationary. The guiding information behind is non-stationary. And then the other major thing is that we didn't want a whole world spatial variability model, one model for the whole world. So we have a locally measured spatial variability model behind the interpolation, locally measured per point in the map. And this to us is really important. So we use an inverse distance weighted method, which is very refined. For instance, the distance metric uses water depth as well as spatial distances. And also it's a logistic function so that the classic IDW peakedness is dealt with. So this performs really well. It performs really, really well around seamounts, reefs, canyons, and so on. So it does really take notice of those topographic elements in tracing the sediment character around the ocean floor. That being said, I'm totally open to new methods like AI/ML, and in fact, we have used them ourselves. All right, so here's a very important issue, and I'm not going to tediously go through this. What I want to do is just to illustrate the ways in which we're feeling our way forward with building this large data set. And as we're feeling our way forward, we're constantly measuring the uncertainty. What is the plus and minus on this? How do these things cross-calibrate? How can we find irregular data? And then how can we report uncertainties going with our outputs? What should I point to here? Oh yeah, when we're dealing with the word-based data, a really important consideration is what happens if you don't know whether the sand is carbonate sand or terrigenous sand. And so we always have an unknown class where we can't say what the composition is of something or the grain size. And so those unknowns are allowed to rise to 5 or 10% of the total. And after that, the sample fails and we won't get output. So we're really all the time concentrating on the reliability of the outputs and what do we need to do to keep that high and what do we need to do to get rid of bad input data. Okay, so as an example of calibrations, here's one for Jan Haaf, who's on the call this morning. And Jan called this the WOW diagram many years ago. It does only apply to one data set, and there are characteristics of that data set. But basically, we're able to get a 3% median average deviation on mud values between the analysis data and the word-based data. So we thought this was a really good, actually it was the first time we did it, and that calibration turned out really well. So when we're looking at word-based data relative to analytical results, you're working in the 16% and less uncertainty bracket quite often, but there are many provisos. Okay, so how do people get dbSEABED data? Here's one of the displays, and this will go live back on the web later today. So this is just a browser, and let me see, here's a video showing me browsing. Click on it, go down. This is a gravel, sand, mud, rock coloration. You can go right in, and then you can click on a point and you can find out what the situation is at that bin, at that data bin. And here's another one. You can see the amount of rock, the grain size, carbonate colors, and other parameters where possible. So you can really browse through this here. This is 0.1 degree bin resolution. All right, how to obtain the outputs. We have a public level and we have a by arrangement level. So the public level is 0.1 degree, and anything with a finer resolution than that, you will need to pick up the phone and call us. And there are actually good reasons for that. Over the years, we've had trouble with pirate fishing fleets trying to get our data, particularly on where the rock reefs are. We had a lot of that down near the Falkland Islands, Las Malvinas, and Then also countries that are prepared to donate their data, they don't want really high resolution maps offshore of their harbors or their choke points published. So 0.1 degree is a suitable compromise where people are still happy to give us the data, but we don't reveal everything about their sensitive zones. All right, so by arrangement, call Gustav. He's a great guy to work with. We do produce mappings, even global mappings down to 1 kilometer. The number of parameters is actually considerably wider than I've shown this morning. And we're always interested to make new sorts of outputs. For instance, the phycologists, the algae people, have a different idea of what hard substrate and soft substrate are than usual. And so we did design something for them. Point data and metadata, of course, come with all the deliveries. All right, and now a global seabed project has to be collaborative, and that's really the fun part. Here are some names from the present and the past. I really point out Thomas Weber from Germany. Marshall Hall was the one who gave us our first contract. And then many people to thank for data and ideas. The Pangaea database is in, most of it is in dbSEABED where it's relevant. And I do really pay tribute to the Pangaea people. Okay, thank you, Gustav.
Thank you, Chris, for that presentation. I'm sure we will have many people who wants to ask many questions. We will save them to the end, but you can keep posting them in the chat. I would just want to testimony for the usefulness of the data. I first ran into it when we did the marine spatial planning in the West Indian Ocean, and Chris provided some really useful data for us for having an idea of where the habitats were. And I think this is why we really were so happy to collaborate with Chris too, that this is a data set that has so many uses, and it's foundational for species modeling, benthic modeling, understanding habitats, and many other things. Okay, let me share first. I can't talk and share at the same time. Okay, so a little bit about who we are. So Hub Ocean, we're a non-profit tech foundation. We're based out of Norway, but working globally. We work for actions to improve ocean health and provide fit-for-purpose data. We also have a very exciting sister organization, Rev Ocean, which is a one-of-a-kind research vessel that is going to be in operation starting 2027 for what it looks like now. And she will be an amazing ship for deep sea work. And we are essentially the ocean data platform for that work as well. So we're much looking forward to that. It's been in the making for some time. In the center of what we do, we have built a cloud-based ocean data platform. So the platform is essentially an open data catalog where you will find the data that we look to today, and I will show you in a little bit. This catalog is we have put useful data in there. It's not the whole world, but we try to really bring useful data in, and we're building it all the time. It is also built to be very fast and interoperable. It also has your own data space. So this is quite, I think, exciting. It's a way to use the same kind of technology through our API, essentially, to put your own data in and share it with others. And ultimately, you can also publish things into the catalog. And I think this could be one mechanism to get more data for Chris, for example. And then on the other side of the platform, on your right there, it's how you can consume the data. So the platform really can be sort of the back end of other places. So, it could power websites and apps. There is a SDK for Python and R that you can work with the data through. We have workspaces that is using that technology. We have our own HubOcean Jupyter Lab environment. It started off with only Python way to connect to the platform, but we just have the first release of the R SDK as well. So now you can connect to the data through R, but you can also work in your other favorite spaces like Google Colab or GitHub Codespaces. And then there's integrations into GIS. So I will show a bit of this today as well. So the data can be used with OGC features and streamed into GIS, for example. A little bit of different user stories around us. We are quite dedicated for industry data, industry to share data. One of the first examples that are still very much active that we had was Aker BioMarine sharing 14 years of acoustic data from their fishing operations. From Antarctica. So that sits on the platform, you can access it. It's been used for some pretty great science, I think, to connect predator and prey relationships. And it gives you a view of that a science mission really can't, because the fishing fleet are there every day for every season. So it's uncalibrated, but still really valuable. And we will have more of that data coming. And there's actually going to be a bit of a story coming out soon with some example notebooks, how you can work with that specific data. Another sort of showcase is the data sharing we did together with survey company TGS, where they were able to release a number of mammal and turtle observations in Brazil, which really made a lot more data available in that region of the world. And we helped go from the Excel spreadsheets you might typically find to an organized data on ODP and then onto the global repositories, dbSEABED. Two other cases is the platform can also be used to strengthen, for example, research data management and have another place to put your research data. We have an example with Basiruto Center for Scientific Studies in Mozambique, who are working with us now to get some of their data onto the platform. And then the example of today, collaboration with data providers, where we really help get some really useful data even more accessible in this world. So I won't dwell on this slide. I'm going to try to cover quickly how you find and explore data on the platform, how you can create your own data collections and data sets, and how you can work with that data and visualize it as well. So there's two resources here for you. One, and I think there should be a link in the chat. I don't see it right now, but you can go into the platform. For those who haven't signed up already, I'll show you what it looks like. You can do that during the call or after if you want. And then there's also a little resource page there on the right that just kind of shows you the different steps. It's not a carbon copy of today, but it gives you some nice links to get going. And with that, I'm going to go to the scary part of this demo, which is actually live demoing. And hopefully that will work. Let's see, I'm doing something strange. Okay. I hope you all see our web page now, unless you see that screen. So this is just HubOcean's web page. There's plenty of information about us. There's an about section with frequently answered questions as well. But here you can just click on the platform and you get to the login page of ODP. So ODP now, I'm not signed in, and you have access to browse our catalog. When you go in and browse the catalog without sign in, you can find the data, but you do not have ability to download the data, and you don't have access to the workspaces and your own My Data space. So I will start with signing in. For those who want to do that, you go to create an account. You simply put in your email, You put in a little bit of information about yourself and hit register. And I've done that, so let's move out of there. So I'm going to sign in. Now, when you're signed in, then you have both then the catalog where the open catalog sits. You have the My Data space, which I will go through in a bit, and you have the ability to go through workspaces. There's also a documentation page that shows you examples how to work with the platform through code and other places. And there's also a GitHub link there with more examples how to work with ODP. Okay, so maybe first of all, let's go and find dbSEABED, which was released just today. Let's go for... So you can search, the data is arranged in datasets and data collections. Not every dataset have a collection, but essentially it's just a grouping, a forced grouping that you can choose to have around a survey mission, around a certain delivery, or what you want. So in this case, we have a collection for dbSEABED. So the really interesting things happens actually at the data set level. And I think we can maybe go and have a look at the hard soft bottom mapping, which is one of the layers that Chris showed. And when you go in here, you both have the metadata that was put in, but you also have supporting information and files at the bottom. You have a key to connect to the data and also links to OGC features for connecting it in your GIS. The platform, I will show you in a bit also the different file formats. The platform is currently, it has preview functions for certain files. So for example, we can see Chris' image that he created for the data. We can go into some of the reports, gray literature, or what else that is associated with the data. You can immediately see it here, or you can download it, and you can download the actual file. Now, so you can do that. It's quite fast. You also have file metadata for the files, and you can. This time it's a global cover, so it doesn't look so exciting, but you will have that cover as well. Now, this is the file data, and since these are rasters, we currently we can work with them directly on the platform, but they are essentially for download at this point. The place that we've spent most of the time developing the fast backend is actually on tabular data. And this is something we worked to make really large data available on the platform. And now I clicked on the actual points of the locations that Chris used to create his maps. Now this is only the metadata, but it is also the spatial location of the points. So in this case, we have this functionality of providing statistics about that whole data set. So here it has 4.3 million rows, and you can already explore. Oh, sorry, I clicked. I did something dumb. Okay, so you can already here explore what is in these columns. The metadata we have on dbSEABED here is, for example, what kind of data is available in the full database. So is there texture data available? Is there composition data available? So you can see here, for example, that 65% of the data has texture data. And we can then also go and filter that spatially. So there's already here you can start exploring the data. Now you can hit this explore table. And then you can actually start already here in the UI exploring and filtering and working with the data. This feature here only shows you the first 100 rows. So there has some limitations for really large data. But you can already go in, you can hit, for example, the spatial filter, and we can make you can check what is in a certain location. Let's try the Oslo Fjord where Hub Ocean is sitting, for example. And we could filter on other columns here as well. We could, for example, we could put in a thematic limitation or a max min value if that was in the column. Now I'm going to apply that filter, and then you get essentially that piece of the data, and you can download it, and you can look at it in here as well. This is a fairly large data set, so it takes a couple of seconds to do that. Actually, since that is spinning, I'm going to show you something else while we do that. So another data set is that I think is quite nice. It's a global data set on protected areas. This is also in vector format. It's quite large, and it has lots of information about protection, something that you might want to combine with dbSEABED. So here again, you can explore this data already here in the UI. You can make lots of filters, and you can visualize it on the map. But there's a little trick that just shows another feature that will be available for all soon, and that is that we've built a vector tiling function around the platform. So here you're actually tiling the whole data set, and this we're constantly working to make this even faster, which is good when the data has millions and millions of geometries. But it has seen an already huge increase in speed this year, and I think we're going to see another bump. So here you can already in the UI visualize data very quickly. Okay, so back to where were we? Okay, so our data filtering is done. So here we can actually now see the data around the Oslo Fjord. It had 185 samples. We can see them. We can click on them, and we can see the information that's there. So, and then you can export. The export options are Parquet, CSV, and GeoJSON, and that's also currently the options we support for ingesting data. But yeah, so you can export the data here, and then you will get what you filtered for. Of course, you can do all of this through the SDK programmatically as well. Okay, so let's go back to perhaps the dashboard. So I will show you how you can also upload your own data. So if you go to your own data place, you can create collections, and you can add new data collections. So let's create one for dbSEABED, for example. So actually, I've got some data from NGU that we were working to integrate in dbSEABED just this summer, and I know, Chris, you're still working on that data. And NGU is actually having a Christmas party as we speak, so hopefully they'll come in and see this in the next couple of days. And so hello to NGU. But let's see what it actually looks like when we put that data in. I got the data from ArcGIS geodatabase that Chris wasn't super fond of, so I thought, why not share it here? And then we can do. There was actually a data set on the way to be published in Emonet, and they kindly gave us access prior so that we could integrate it. I'll put in something. So now we've just created the place for uploading the data. Here you can then manage the metadata, and you can manage access. That here I could, for example, invite Chris as a collaborator. You have to have the email ready. I didn't have that. Anyway, here you just input the email of the user, and they will see it. There's also a shareable link, which means that the data will be accessible for anyone that's signed in on the platform, but not searchable in the catalog. Okay, let's get to just uploading some files. Let's go. I've actually just have some data ready. If you input a CSV file, it has to be, of course, you can put anything in a CSV from an Excel document. So you have to ensure there's a geometry following a WKT formatting or WKB. In this case, I have a Parquet file that's also a little bit faster and already formatted, or you can throw in a GeoJSON. Now, because it has those right attributes, when I upload it, the platform recognizes that, and it allows you to ingest this as a table. That gives it all the features I showed you already. So when it's a table, we can now, of course, we can input lots of metadata. I'm going to save us some time and not do that. But you can go and edit the table and add information about the columns. But now we can already go and explore this table, and this just happened live. So here's again all of the data from NGU. We could filter it. They have the full geology data in here. So we could so let's see if there was something fun. I thought I saw something. Anyway, we could filter on. Let's filter on color then. And you know what? We should also add a spatial filter. And we can see if Chris is going to get some more data when we add this. Okay, I guess let's remove the thematic filter. That was maybe a bit dumb because it doesn't show us everything. Let's look what everything looks like. Anyway, so here we can already then explore the data. There's another 369 sites that Chris can add. So this is going to be a substantial update for the Norwegian part of dbSEABED when it gets integrated. And the other fun thing is that now the data sit here and we have this ability to collaborate, and we can actually now through the platform, we can start collaborating on the data itself. So those with reading and writing rights can actually amend columns and rows, and we can start doing work together already on the platform. And we've done some quite nice demos of that, how that looks like in some of the webinars we've already done, and we will do a deepening webinar series this fall. Sorry, fall next year to really go through these in more detail. Then there's also this button, request to publish. So that means that you can request to publish this in the main catalog, which is great. So if the data you just have the rights and the license is there, the data will end up in the catalog. And actually today, we for the first time generated on our own digital identifiers, DOIs. So dbSEABED data have that, and this is a functionality that we're building now for the science community. So you don't need to go to Zenodo or one of the other places in case you want to generate it for new data on the platform. Okay, quickly, I know I'm running out of time a bit. I'll just show you quickly what the workspaces looks like. So in workspaces that we have, we have a full Jupyter Lab environment with Python and R being the main ones. We have a really cool, I think, GIS sort of new project in Jupyter that allows you to do some sort of QGIS work directly in the notebooks. So for some of the demos we did last week, you can check them out. Me and Tom is on this call. We actually collaborated to put some coral maps together. And then we did that using the power of the platform and some of the server-side compute that there is. You can create aggregations using H3 indexes, for example, really fast without having to move large data like Allen Coral Atlas and those with many geometries in them. And then actually you can if you want to already display the data here in the GIS in the cloud. This is fairly early days, I would say, for this GIS system, and we're also building out the features of the platform itself to do more multi-layer support and visualizations. But I think it's really nice with these open source places. Okay, last thing I'll show before it's time for questions. Let me just find the sharing button. Show one more thing. Yeah, I just want to mention that Ocean Data Platform, we do have OGC features as one of the ways to connect to the data. And actually, I'm just showing the dbSEABED as a file that I downloaded here. We did not yet have a full raster support. It's coming, but we do have it for all the tabular data. So this is actually the dbSEABED database shown through OGC features. So you can fairly simply connect to the catalog. There's a short introduction in the documentation section how to do it. You generate an API key in your user account. But here you also have, for example, other data on the platform, like the seamounts of the Royal Ocean. We have 2 data sets, and you can kind of conveniently work with them here. We have that protected seas data, but there are, of course, limitations when you work with data streaming. So I think this is one of the things with working locally. You have to move the data, and it's always a barrier. So some large data, maybe it's not the best to work this way. Right. Did I say everything? I think so. Okay, so that's all for my live demo. Maybe Tom, did I miss anything important?
Not that I'm the arbiter, Gustav, but no, I don't think you did.
So, Gustav, there might be some technical questions.
Yeah.
From people.
If you bear with me, we will do a very, very quick poll before we release the questions. So we will go through them quite quickly, and you can keep answering them. And you don't have to, of course, but we deeply appreciate just your input. So I'll just go through the questions. I'll launch these, and they'll stay there in the poll section. So just a little first one. If you can just put in a word or two about your experience of this webinar, and then we'll get a little fun word cloud. And if you don't think of one right now, we'll go back to these in 5-10 minutes or so. I see some nice words already. That's great to see. And then, okay, I'm going to move us on to the next question to save us some time. Okay, so just kind of which part of the webinar was most relevant to you, and you can click as many options as you want, but just to see this is the dbSEABED data itself, how it's actually on the Ocean Data Platform, interest of putting your own data up and working with it, visualizing data in GIS using ODP, and share data. And then I've got one directed to, there's just 2 more, if you bear with me. One directed to Chris. So from the dbSEABED global substrate maps, which of the following applies to you? Would you find it useful with these public 0.1 degree maps, where you mainly need high resolution data? You may need different parameters for the maps to be useful, different themes. Are you interested in contributing to the project with ideas or data? And I'm sure there'll be quite a few who already have contributed to this project on the call. And then, or if you're just primarily here because you're curious, explore. And then, okay, I will just launch the last one. Sorry for the blizzard of questions, and then we should be done. So what kind of support will be most helpful for using a platform like ODP, should you want to use it? We're already planning a deeper webinar series that will sort of dissect the platform in its component and go a bit deeper than what we can do in this kind of introduction. Do you need more handheld trainings, more interactive trainings or courses? You might even have an idea for academic courses something that we're also looking into for next year. Actually, if you have ideas and know about students, or courses that you think it would be quite interesting to work with the Ocean Data Platform in a small or large part, we're very much interested to hear from you. Yeah, then there's the online support, chats, forums, documentation and examples, or you're the kind of person who just have at it. And that's all for my question. I'm sure we have quite a few in the chat. Tom, are you moderating a bit?
I can see there's a question from Filippo asking to repeat the relationship between dbSEABED and HubOcean.
Yeah, do you want to have a go, Chris?
Yeah. So as I said, most of my work, and there's like a lot of data aggregators, my work is at the coal face. So it's a different set of skills, really, to take data and bring it into packages that suit users. And you remember, those users are not geoscientists. They might be whale acoustics or so on. So, it really, I look on HubOcean as a way of translating my granular work into something that other people can easily find and digest. And, it's really nice that there's the presentation side as well, which it's like looking at works of art. And for me, that gives me a lot of pleasure to see my data sets in that environment, right? So it's a collaboration that is good. HubOcean have the required technical finesse, and they appreciate things like uncertainties. So it's easy for me as a scientist to work with them. They are scientists too. So I think that's it from my point of view, Gustav and Philippe.
Yeah, thank you. And just right now we're supporting Chris' work a little bit, and we're looking, to put these public maps out. Hopefully, we'll keep on doing this for a number of years, Chris, to keep these maps fresh and up to date. And like we said before, I mean, Chris, you're a very collaborative person. Of course, you have many collaborations around this world, and we're happy to help, strengthen those as well. And we're also looking, of course, for good use of those special products on the high resolution side, where ourselves we're looking to help transform industry to more sustainable practices. So we have that link as well, where we are looking for ways to bring in more environmental data into industry as well, for the right reasons.
Right, and that's something else I would add as well, that we know we share common goals for the ocean, right? So we want better ocean management, stewardship. We're quite happy for technology to play its role in that, right? To help the oceans along in difficult times. So yeah, our goals really align.
Gustav and Chris, there's not a question in the chat, but it's just I noticed in one of the polls that there were quite a large number of people on the call that asked how that they need access to the higher resolution map. So maybe you could just spend just a little bit of time talking about, well, Chris, you already said the reasons for not sharing that publicly, and they're very good reasons for that. But they are available and they can be accessed. But maybe you could just talk a little bit about the process that we've been envisaging of how people could contact you and work with us to get access to those high resolution maps.
Yeah, so there are a couple of aspects, and essentially they're summarized in a data agreement that dbSEABED has, where the high resolution data for use only in a specified project, and the project is specified with an abstract. Depending on the work requirement, sometimes we ask for a contribution of data or publications or money or whatever. So I find that If people put skin in the game, we actually get a better result in terms of publications and so on. They feel duty bound to do something with the data that we've spent time preparing. So there are many aspects to this. I understand that the high resolution data, people want it more, but you know, even with 6 million samples, they're pretty sparsely spread on the globe's surface. So when you start going to 1 kilometer resolution, you can really only mathematically justify that in areas of really dense coverage. Otherwise, it's like overfitting the model. So yeah, I think that the 0.1 degree is an extremely useful data product for almost all projects. If you start coming down to 1 kilometer, it's like using too many significant figures. But some people really want it, and we can produce it. We do have the whole globe mapped at 1 kilometer. So yeah, it's available, but I'm not sure it's the right decision in all cases. Okay.
And yeah, I guess from our side, I think we are very happy to support these kind of custom-made maps as well to make it easier to create them. And work together with Chris on this as well. So it's something that we're collaborating on.
Yes. So the major thing that I'm looking forward to forming a good collaboration on is applying machine learning and AI to these data sets. I think that is such an open field, such an exciting field. And the other one is human impacts on the seabed, like junk, right? So there's lots to do. Yep.
Right. Tom, is there any more questions? I'm screening through them.
There wasn't a question. There was just a comment from Dayton pointing to another project by BGS, the British Geological Survey. I think it's probably one to follow up on, Gustav and Chris. So other than that, I don't see any other questions.
Great. So thanks a lot also for the input you gave on the questions. So you can all see them there in the chat. Maybe I'll just comment both. First, thanks for the nice words. Yeah, and then I think, like we said, many here to see the presentation from Chris. Quite a bit of interest in the platform. Actually, I think with higher than average interested in data analysis in Python and R. So I think we have quite a technical audience, Chris, compared with some of the other webinars we've had, and also interested to visualize the data. And actually, some are interested in sharing data on ODP. So that's great to hear. Just reach out to us, and we can make it even less painless than the platform itself can provide. And then, like we already went through on the usefulness of dbSEABED, many wants higher resolution. People all want higher resolution, so it's expected.
Contact us.
Yes.
We've got it.
And then, and on the last one, this audience seems to be very keen on good documentation and examples, so we keep improving those. And then, very happy if you see some of you joining us on the deepening series of the webinars. And for courses and trainings, actually, I would much appreciate if you write me an email. We will, when there's something official out, we will of course post that so you can all see it. But if you have specific requests, come and let us know, and we can see what we can do. I see a question from John.
Okay, Gustav and Chris, I just want to say at the end that I'm very much appreciating the cooperation between both of you. And I have another view to the story. I mean, you were talking about high resolution and going into the detail, into the local resolution and the information. What we are mainly after is the global comparison of data, have a global view on the story. And that means Chris knows he's a member of our team, and we are working in particular with the so-called marginal Cs. And what we are after is a comparison, to find a comparison and similarity functions that we can use to realize and to quantify this kind of interrelation on the global scale. And I do see special interest in that view and in that scope that may be added to the local and high resolution information and connecting that on a local, very specifically area. So thank you very much for the presentation. Appreciate it.
Yeah, you're welcome, Jan.
Great. I think we ran a little bit over time, but that's great that so many stayed. And I see many friends that I haven't spoken to a while in the that has attended. So great to see you all. I just want to again thank you, Chris, so much for being with us here today. You're actually going to run another webinar in 5 hours or so, which is even more fun for me because it's going to be late at night for a US audience. But yes, thank you so much, Chris.
Yeah, it'll be nice to speak to Oceania. So can I reverse questions to the participants? So does anybody would anybody like to suggest a different use, an unexpected use of the substrates data? What's out there? What are the ideas that are out there?
That's a great
reverse questioning.
Okay, feel free to put ideas in the chat.
Well,
if you
yeah.
if you then wake up and you come up with a great idea tomorrow morning, why don't you send us an email and we'll love to hear from you.
We'd like to collaborate. Yes, yeah. So let me see. I was reading about how concrete structures shift under hurricanes on the Florida platforms. They travel miles on the Florida under a hurricane. Concrete pipes and blocks. So you know the sediment and the seabed quality provide the friction factors for the movement of those objects during hurricanes. So you know it's a very imaginative field, and I'm looking forward to fresh ideas how we can use this data. Yeah.
Great point, Chris. I see we're way over time, but that I think it's fine for me to stay a little bit longer. So I see we have a Taylor has his hand up, so you know, please have a go. And if you have to leave, thank you so much for joining us. Taylor?
Hi, sorry. I think I had my hand up earlier and then I lowered it whenever Chris was asking some questions about interest in collaboration. I guess I will just use this as the opportunity to say we've been doing me and another colleague on the call, Ben Frampus, do a lot of geospatial machine learning predictions on the global scale. We've been doing that for quite some time, and then we've been using those into deterministic and empirical models. So I'm basically tying together many different machine learning geospatial predictions towards modeling efforts to get a more spatially variable result for different properties of the seabed. So that's kind of our interest. I planned to send a follow-up email, so hopefully we'll be in touch, and this webinar was fantastic. Thank you.
Very good, Taylor.
Great to hear. Okay, I think we have to close it. Thank you so much, everyone who contributed and joined us today. There's going to be a recording. We're going to send it out in some time. And yes, please reach out to us if you have questions or other things. See you.
Good luck, everybody.
So thank you very much.
Cheers. Have a good afternoon.
Okay.
Bye.
Enjoy the day.